If you can't explain it, you don't understand it. That sentence sounds simple, almost too simple. But it's the most reliable test I know for real thinking. Because today, we're surrounded by numbers, charts, rankings, percentages, data-driven, headlines. And the dangerous part is not that people get things wrong. The dangerous part is that we feel right without ever thinking. So here's a challenge for the next 20 minutes. Not to memorize rules, not to chase correct answers. Just to notice one moment. The moment you think you understand, and the moment you can actually explain why. This is what fake understanding looks like. You open a chart, you see a line going up, or two bars that look different. And your brain instantly says, got it. Not because you analyzed it, but because you recognized a familiar shape. Recognition feels like understanding. It's fast, it's comfortable, and it lets you move on without paying the cost of thinking. But if I stopped you and asked, explain what this means, step by step, most people can't. They can repeat a conclusion, but they can't rebuild the reasoning. That gap, between a confident feeling and a clear explanation, is where data starts to mislead. So here's the only question that matters. Could you explain it to someone else? Clearly, carefully, without hiding behind big words. Not, I think it means. Not, it's obvious because. I mean. What exactly are you claiming? What evidence supports it? What would change your mind? If you can't answer those things, you don't have understanding. You have a feeling. And feelings are easy to manipulate, with charts, with averages, with headlines, with AI-generated summaries. In this video, I'm not trying to make you faster. I'm trying to make you explainable. Because explainable thinking is how you stop getting fooled. Data feels objective. Numbers don't argue. Charts don't have opinions. That's why we trust them. But data itself doesn't explain anything. It just sits there. Meaning only appears when a human starts telling a story about it. And the moment a story appears, interpretation enters the room. That's not a bug. That's how understanding works. The danger begins when we forget that interpretation is happening. At all. Interpretation happens automatically. You don't choose to interpret data. Your brain does it for you. The moment you see a graph, you start guessing what matters, what's important, and what the story might be. That's not a mistake. That's how human thinking works. The problem isn't that we interpret. The problem is that we don't notice when interpretation has already started. And once you miss that moment, explanations start replacing thinking. Correlation feels causal. When two things move together, your brain jumps to a story. One causes the other, not because you proved it, but because it feels right. This is one of the strongest shortcuts in human thinking. We see patterns and we complete them into explanations. The dangerous part isn't that we do this. It's that the feeling of certainty arrives before the thinking does. And once that happens, asking better questions feels unnecessary. Your brain is built for stories. Long before charts and data, humans survived by spotting patterns and turning them into explanations. If two things moved together, assuming a cause was often useful. That shortcut saved time. Sometimes, it saved lives. So when your brain sees correlation and starts telling a story, that's not a failure. It's a feature. The problem begins when we keep the story and skip the question. Pause. Before you explain. This is the moment most people skip. Not because it's hard, but because it feels unnecessary. The story already makes sense. The chart already looks clear. But that pause is where thinking starts. It's the space between, this feels right, and, what exactly am I claiming? What exactly are you claiming? Not what the chart shows. Not what feels obvious. What are you actually saying is true? Are you claiming that one thing causes another? That this trend will continue? That this difference matters? Until you name the claim, there is nothing to evaluate. No evidence to check. No assumptions to question. If you can't state the claim clearly, you're not thinking yet. You're just reacting to the picture. A claim is not a description. Describing a chart means saying what you can see. The line goes up. The values are higher. One group is larger than another. That's not a claim. A claim says something about the world. It says what matters, why it matters, or what should happen next. If all you can do is describe the picture, you haven't made a claim yet. And without a claim, there's nothing to test. Evidence supports claims, not the other way around. Data doesn't speak by itself. Evidence only matters after you know what you are claiming. The same chart can support very different claims. It all depends on what question you're asking and what alternative explanations you're willing to consider. Without a clear claim, data isn't evidence. It's just numbers waiting to be pointed at. What would change your mind? This is the question most people never ask. If no possible evidence could make you reconsider, then you're not holding a claim. You're holding a belief. Real understanding includes the conditions under which you would be wrong. It means knowing what kind of data would weaken your conclusion, not just what supports it. If nothing could change your mind, you're not explaining. You're defending. Let's test this idea. We've seen a pattern. We've felt a story forming. But here's the real question. Does this data actually support the claim? Does this data actually support the claim? But some people don't stop. They ask one more question. What would change your mind? Not what you believe. What would disprove it? Now ask it here. What would change your mind? In this graph? Most people answer with this. A stronger trend, more data points, a bigger number. This would change my mind. A plausible alternative explanation. That fits the data better. Same data. Different explanation. So the real question is not, is the trend stronger? So the real question is this. What else could explain this pattern? Sometimes, the answer isn't in the data. It's in the context around it. So here's the question. Does this explanation actually fit the data better, or does it just feel right?